So consider the following. This guy's acting kind of puny on me. There we go. If I have x squared times x to the third, what would you do? What's the meaning here? Now, I like what you guys are saying. Now, some of you probably remember the property that you learned a long time ago, but what you're telling me is what it literally means, which is x squared is x times x, right? Times x to the third is another product that has been condensed. Do you all agree that's what it means? Well, then how can I simplify this? How can I condense it back to a nice, simple expression? That's x to the fifth. Because when you look at this, this has 2 factors of x times 3 factors of x. We said factors were pieces of the multiplication problem. So if you were to string all of these out, like we wrote here, you have a total of 5 factors of x. Do you all agree? Now I'm going to give you the property, but I don't want you to memorize the property so much as you understand the meaning behind the property. Just what we're showing here. You are not always going to write this out. You're going to see examples where it makes absolutely no sense to do that. So we want to talk about the product rule for exponents. So if I'm multiplying expressions like this, x to the a and x to the b, as long as these guys have the same base, then just like you saw above here, you can combine these guys. So what am I going to do? What does that equal? What do I end up doing with those exponents? AB? If you say AB, what does that mean? That means multiplication. Did I do 2 times 3 to get 5? What did I do? I added those guys, so it's A plus B. Now notice, this is your same base, and you keep that base. You don't change it, because you're trying to figure out how many factors of that particular base you have. For example, if I have x to the 5th times x to the 8th. Now I'm not always going to show all of the work that I'm showing right here, but just so you see how the product rule applies, it would say that you would take these exponents, 5 and 8, and you would add them together. You keep the base the same. The base doesn't change. It's still x. And so this, of course, is just x to the 13th power. Like that. Do y'all agree? All right. What if I had x to the 15th times x to the 10th? That would be x to the 25th. Now notice what I'm not saying here. We do not say x equals 25. We do not say that the answer is 25, but we say the answer is x to the 25th. Okay? X to the 25th. Because this part right here says you have 15 factors of x. This says you have 10 factors of x. How many factors are stuck together if I were to string it all out? I have 25 factors altogether. Do you all agree? Okay. What about x to the 43rd times x to the 54th? So you got this guy very easily by just adding those exponents, right? 43 and 54 is 97. You know what bad kids do? Bad kids, and I know this from experience because I've had these in my class before. Bad kids will do this. Oh, x to the 43rd. Okay. I know! Well, see, this is the thing. They just keep on going. Right? And you know how I know it's bad? Because you can see on their paper where they've done this. 1, 2, 3, 4, 5, 6, 7, 8. You see the little dots above each of those guys? And you know what was really funny about this is I was grading this on a quiz about 12 years ago. They got it wrong. What was even funnier was that this particular student had told me that they did not need to be in my class. That they didn't even know why they were in my class because they, quote, took pre-cal in high school. If you took pre-cal in high school and you were successful in it, you would not be doing this. This is what we call what? Waste of time. I don't even know what to do. Don't do that.
You count on if you do that?
You know what? I will not count off. I'll just give you something like x to the 430th times x to the 1972nd. That's horrible?
No, that's horrible that someone would do that on a test. That's like making all those X's. I don't understand why.
Yeah, that was
someone would
about
do
fall of 2001, I think.
It was a college class?
It's a class just like this.
Did you pass?
Did they pass? If you're doing that, you're probably not passing. Now, what about 3 to the 7th times 3 to the 4th?
9 to the 11th.
9 to the 11th. All right, now that's very interesting that you say that because I want you to think about this.
Well, it's not a text.
You know how I like my thought bubbles, right? If I said y to the 7th times y to the 4th, what would you give me here?
11th.
Y to the 11th, right?
You don't change it.
Oh, yeah.
Did my base change here? Because what you're doing, and now this is the thing, you understand, don't memorize the property, but understand how it works. This says I have 7 factors of y, and I have 4 factors of y. How many factors of y would I have altogether?
11.
So back up here, this says I have what?
3.
I have 7 factors of 3.
Well, you were pointing at 3.
4 factors of 3. So what do I have altogether if I expand that?
11 factors of 3.
I have 11 factors of 3.
Didn't you also say that we're not solving, we're just evaluating them? Or
I'm simplifying. Now you could work this out and figure out what 3 to the 11th is.
that's not what you want us to do?
I don't know it off the top of my head, so I'm not going to worry about it.
Okay.
I know it's kind of a cheap answer, but that's the answer you get from me right now.
So you would multiply 3 times like this?
No, because look, the base stays the same, right? Was there anything up here where the base changed? No, because those exponents are telling you how many times you see that base in the multiplication problem. And so if you say 9 to the 11th, you're telling me that you would see 9 11 times, but you wouldn't. You would see a factor of 3 7 times here, 4 times here. So if you did write all of those out, all you would see would be factors of 3. Okay. All right. Let's look at this one. We have x to the 14th, y to the 5th, times x to the 11th, y to the 9th.
X25 over 2. How do you say it?
X to the. So you're saying all together, it's important to note that this is all multiplication, right? And what we've said before is that the order doesn't matter when you're multiplying. So how many factors of x do we have altogether in this product? 25, and how many factors of y do we have?
14.
We have 14. Any questions about that?